for example, fly from one continent to another. Some things you take in routine, that you do and don't think anything of it. It was impossible for your parents, or your grandparents. That'll take you a little while maybe, but write down 2 or 3 of them. In the meantime, I'm going to try to hook up this apparatus to a different supply of hydrogen than I'm used to. I usually have it in a bigger can with a different size tube on it, but I think I can get this out. I'll shut up for a little bit and let you put that down. Because he got us to think beyond what we had, well, we're just learning. I remember in the geometry class, he told everybody in the class, if they really wanted to get an A in the class, all they would have to do was find some problem in any high school math book that he couldn't solve in 5 minutes. And that would give us an A for the year. I thought that was a lot of fun. I worked more math problems trying to get a different answer than the answer book than I'd ever done before in my life. And it got me to thinking in terms of what's possible and what's impossible. We did find 2 questions, incidentally, where we couldn't get the same answer as the textbook had. And he proved to us, without any doubt, that the textbook had a mistake. Because he showed us 3 or 4 different ways to get the same answer that we kept getting. And he was right. The textbook authors and publishers had made a mistake. And so ever since then, I know anytime I find something I disagree with in a book, I look real carefully to see if it's a mistake, and boy, we find a lot of them. I'm sure you've run into some of them too. One of the things he told us in science class, in class on aeronautics, was that it was everybody's dream to go somewhere else, to the moon at least. And that was one I knew was an impossibility, and he proved it by showing at that time, that was, well, I was in high school 50 years ago. At that time, we hadn't broken the sound barrier yet. So he said some of us probably would live long enough to fly to the moon. But if we did, we'd have to take our family along and teach our kids to fly, because we wouldn't be able to live long enough to fly back, because it would take more than one lifetime to go to the moon and back. In less than 20 years, we've gone in there and back in a week. But any scientist at the time would have agreed that he was right, that we would never be able to go to the moon and back. No, one of my dreams became to go to visit some other planet beyond the moon, and I may not live that long. But I'm pretty sure some of my grandchildren will. Because things will change a lot faster in the next 50 years than they have in the past 50 years. I would guess, and I think it's a logical guess, that by the time you get to be the age I am, and I hope you do, that you'll only be halfway through life. Because I'm not 70 quite yet, a couple of years to go. And I expect that by the time you get to be 70, it won't be uncommon for people to live to at least 150. When I was your age, there weren't very many people over 60. Up until the time I reached at least 55, I thought 60 was real old. And I don't feel that way at all anymore. I can remember back that far when I thought 60 was old. But after I got past that, it didn't seem old at all. Any more than 14 would seem old to you. When you were 6, it probably did. Doesn't anymore. Your mind will hopefully change as everything else around you changes, and you won't. I think that you will learn rather soon, probably before you get out of school. A lot of the things we accept now as fact were really illusions, even though they seem very real. I'll probably get set up before we're through here to show you one that I think is kind of fun to do. An illusion that people use in television and magic shows a great deal. In fact, you can really be very fooled by illusions. How many of you do anything? Do any of you ever work with magic just for fun? It's interesting to see how easy it is to fool some people. I used to make money out of it once in a while in the service. One of the things I thought I should show you is, everybody I think has wished, you don't anymore probably, but at one time earlier in your life, you probably wished you could wet your pants and not anybody ever find out about it. But there always seemed to be some telltale sign, either a spot on your clothes or a puddle on the floor or something, and it didn't work. I put a little bit of sodium polyacrylate in here. That's a polymer. Do you know what a polymer is?
Yeah, it's the glue, isn't it?
Well, it's a big molecule of something, no matter what size it is, it's still one molecule. Most popular ones that you're aware of probably are polyesters, plastics like we use for bags for shopping, and shirts and skirts and everything else are made out of polyester. They're a polymer made by taking one molecule and combining it with another molecule of the same kind until they get really big. And you can cut them, and this is ground up. But it's a sodium polymer, has a lot of salt in it. Sodium, not really salt like we eat on our food, but one of the same basic ingredients. Only it's a polymer. You know what osmosis is? Okay, that's a tendency of pressure, isn't it? To try to uniformly divide something up so it's not one high concentration here and low over here. If I put water in this sodium polymer, it tries to neutralize the sodium in there so that the sodium concentration is the same inside and outside. Now, if that had been in my pants, it wouldn't have shown a sign at all.
Oh, yes.
You saw me pour the water in. That didn't absorb very much of it. Actually, that polymer, which is in very current use right now, will absorb approximately 800 times its weight in distilled water. Wouldn't that answer a lot of dreams? What do you suppose it's used for now? It's got a very important commercial use. People who used that and discovered it are millionaires, because you and I buy this stuff. That's what makes Pampers a little more expensive than other diapers. It's got some of that little powder in it. If you ever take one and cut it apart, you can shake that powder out and do this exact same thing with it. I borrowed some from the biology department, so I didn't have to take apart Pampers. Let me show you. Can you believe that? Now you can.
What does it feel like? Is it hard or is it like
Yeah, just pass it around. No, you can stick your finger in it. It's a jelly. It's like Jello only. If you look at the bottom of it, you'll see it didn't dissolve nearly all the powder that I put in there. What I put in there was about half of one of these. Half, a fourth of a tablespoonful maybe.
Oh man, that's really weird.
Be careful when you pass it around so you don't drop it, because it'll break. But it's absolutely non-toxic. The other main use it's used for is the more expensive sanitary napkins and diapers that older people wear when they get incontinent and can't control their urine. They can go to a movie, they can go to a dance, they can go roller skating, and not worry if they wet their pants.
Maybe those
Because it isn't going to run
we
out.
should give some out. Those who want to go to the bathroom all the time.
Maybe she'll just give you a little bit of sodium polyacrylate.
Yeah.
This is what it looks like. This is very finely powdered, but that's a polymer. You could mix that right, I suppose, and make string out of it, or cloth, thread, because that's what the plastic clothes we wear are like. Can't think of all the different poly clothes we wear, but you're aware of them as much as I am. That's one of the accomplishments of chemistry that would have been a complete impossibility when I was in high school. We never even talked about that. We talked about simple things like acids and bases, and we didn't talk about polymers at all. Any questions on that? Notice sometimes when, excuse me.
Will it stay in that gel, or will it eventually harden?
No, it'll not harden. Usually in the kind of materials where they use that, it just goes in the dumpster. It'll break down with microbes. It's completely, what do they call it? Completely biodegradable. Thank you. I have a hard time getting words back in my head sometimes.
But Grandpa, the
Yeah.
stuff you had at home that was kind of like that, but not that same stuff, they said that it could be used for plants. How would that work?
That's one of the other very important uses for sodium polymers. I got some because I didn't know if I'd be able to find this in school, and you can't buy it in a drugstore. They'll sell you Pampers, but then you can cut them apart and get it. But they don't even try to market the pure sodium polyacrylate. You might want to write that down. You know how sodium is. Polyacrylate is just POLYACRYLATE. When you see some product and wonder why it's more expensive than the other, you'll never find sodium polyacrylate listed on the ingredients. I never have anyway. They sometimes say polymers, artificial polymers, usually what they say. There are lots of natural polymers too, especially in plant tissues. But what I found here in one of the nurseries that I can't even find in South Dakota was a similar product, but it wasn't sodium polyacrylate. I can't remember what it was now. I meant to bring it with me, but when I opened my briefcase, I decided I must put that in my suitcase instead. But it's called Water Lock or Water Save, and it's a similar product, only it's in bigger granules. You mix like a teaspoonful with it in a 10-inch pot of potting soil, and instead of having to water your plant twice a week, you water it once every 2 weeks. Because this does not hold the water strongly enough that what a plant root will take the water away from. I imagine most of you have studied biology, probably all of you. You know that moisture moves up through the plant by osmosis, as well as, what's the other force? It takes it clear up the top of the tree. Make the water go up a wick when you're using the wick for something. We don't use it very often, and except in plants of nature. Can anybody think what that force is? One of the forces you've studied in various science courses. A set of tubes back here to show it how it works, but the smaller the diameter of the tube is, the higher it will lift water against the force of gravity. Because we know the trees don't have a pump to put water clear up to the top, but yet you've seen 200 and 300-foot trees with leaves on the top. You know they're getting water. Now that word slips my mind. You remember what it is?
Oh, yeah, osmosis, I mean, you talked about osmosis, you have transpiration.
Transpiration is the evaporation at the top that
Right,
helps
stop,
pull that up.
and then you also have diffusion.
Yeah. There's one more that I can't think of now. I'll think of it when I'm through, probably.
You know, I was gonna say that, one use that you have, of that, we were talking was, about was that, you know how they're having all the floods? Have they ever looked into using that as,
Flood control?
putting it in bags for flooding?
I'm
And I
not
know
sure.
it breaks down, but,
I've never heard of that, but it's very possible. I know there's a rock that they grind up and used in places like building corners and roof and around foundation. It swells to about 10 times its size when it gets wet. And now that even slips my mind. I had a mini stroke about 2 years ago. And a lot of things like names and don't come back to me like they used to. And usually, in 5 minutes or so, it comes back to me. I miss that because I used to have real quick recall. Any other questions? I was also going to show you some other things that are impossible, that everybody knows are impossible. How many of you know how to cut glass? How do you cut glass? With what? Usually with a diamond cutter or a hard steel cutter. You roll it or scratch it, and then the glass breaks right where you scratched it. I sometimes have fun showing people how to cut glass with the scissors. Now everybody knows that's impossible. But it's as simple as cutting your hair with a scissor, which isn't real simple, but it can be done. I should have asked Miss Duyan, do you have a clear pan about so big, 3-4 inches deep that I can fill with water? If you don't, I'll do it right in the sink. They'll all have to come up here then you see it. Because that was one of the things I thought of. If there were questions along that line, I'd try to.
I don't have, what about with this too?
No, not very well, because I have to use both hands underwater. Can I run tap water into this? Have it plug for
Yeah, I do. I have some rubber stoppers.
it. Okay, good, that'll help.
Okay.
This is the way we usually cut glass. We use a glass cutter like this, a commercial glass cutter. And it's very good for cutting straight lines on glass. Or you can run it around something like a beaker and lift the top of the beaker off. But it's very difficult to cut most shapes with it. Yeah, kind of.
You're talking about capillary action, is that?
Yeah, capillarity was the other force. Thank you. Miss Duyan brought it back to her mind. It's still a long ways from mine. You ever heard of capillarity?
We're going to do that later when we do organics. We're
Yeah.
going to do melting point.
Uh-huh. Capillarity is a force too that will cause something because of the both the tendency for water to stick to itself and the tendency for it to stick to things around it, which we call cohesion and adhesion. Those two forces work together to cause capillarity. And that's the way water gets way up to the top of the tree. This would probably help that process. While I'm waiting for that to run, I was going to set this up. I didn't run everything I need. While I'm doing this, would you read carefully all the information in the back of that sheet on the space shuttle? Maybe before I have you do that, I should tell you one other thing that was and in many minds still is an impossibility. I believe that many of you, if you drive until you're in your 60s or 70s, will be driving your car using water for fuel. I'll say more about that later. This is about an engine that uses your hydrogen and your oxygen for fuel. And that's really what water is. Yeah, read through that and see if they make sense to you at all. The great inventors, many of those had machines like that. Thomas Edison, who probably invented more things yet than any other one person, had many problems, including not being able to write or read very well. He got lost in his own hometown, according to some of his friends. And, a lot of things seemed impossible to him. He told Henry Ford, who was a good friend of his one time, that he was stupid to try to make his car go over 40 miles an hour because physicists had proven without a doubt that if a person ever went over 60 miles an hour, they'd be unable to breathe and they'd suffocate because of the shape of the nose and head. It creates so much of a vacuum on the outside they couldn't breathe in. How many of you have gone faster than that? I used to ride my motorcycle over 120 and I never had problems breathing. But he was an intelligent man and he believed that. He invented what we call the incandescent light bulbs. He had lab assistants that got really disgusted one time. And he said, we're stupid to keep working on it. He said, we've failed 500 times to get something to burn inside the glass tube. And Thomas Edison said, that's not true. He says, what we've done is over 500 times we've succeeded in finding something that didn't work. And that was his attitude in life. If something didn't work, that never bothered him. He'd keep working at his goals until he found something that did work. And he did that over and over. So sometimes when I try to cut glass with the scissors, it doesn't work, but I think it will today.
I don't have any bookends, but
That's
we
that's
can use
great.
these too. Okay,
That's
sure.
great.
Okay.
If you want to come up this way, I'll show you how this works. You won't all be able to see it at once. But as long as you hold glass underwater, its crystalline structure is the same as water. So glass and ice are very similar. You can probably already know that. And so if you put glass underwater, you can cut it with a pair of scissors like you'd cut a piece of paper. I just cut that corner off. One of the interesting things about it is that it doesn't leave a sharp edge like a glass cutter does. I could cut that whole edge off there. Difficult to see, I know. I just cut that distance right there. It doesn't do a real smooth job always. But if you needed something circular, you can make it circular with a scissors. Then you can take a piece of emery cloth or something and trim it off better. Anyone who's cut glass very much knows that if I were to try that up here, it'd shatter the whole piece of glass usually. It's used in industry all the time. It's probably more physics than chemistry, but actually it's a result of the basic structure of that crystal, which is what's glass made from?
Sand.
Sand. We don't think of sand and glass being very similar at all, but by a very simple process, they make one out of the other. Any questions on that? Thank you. That's all I can show you. If you do that when you drain the water, be sure you don't get it in your fingernails. But most of those pieces will have a rounded edge. If anybody wanted to feel that, you could.
That's interesting that you can cut it, yeah, you can't break it underwater.
That's right. Very difficult to break underwater. Do you know how glass is formed? Have you ever seen it done? When they roll sheets like this, they roll it underwater. Well, you know if that had been shattered out in the open, those would have been extremely sharp edges. It would have been like a razor. Yeah. I'm going to use that same piece of glass to show you something else. Very well, because that light is pretty bright.
Is this still bright?
No, I don't think so. Let me see.
Asa, pull those lights, finishing line for this? I'll put this.
I have a little candle here. Shine the light. Can you see two candles there?
Do you need two candles? Oh, okay.
You see the flame of the other one?
Yeah, you don't do
The
it.
other one's in a curved glass. About all you see is the flame. What I was going to show you is that I don't always call this a magic candle because most people don't believe in magic.
Do you really have two candles up there, or is it just a...
What I really wanted to show you was an illusion. And it will appear that the one is burning underwater and there's going to go out on it.
Oh, it does look like
That
that.
wasn't supposed to happen. I must have talked too fast or too loud.
Would you like another candle? I have a
I'll
lot.
light this one again.
I have some other candles if you'd like.
But they'd be different, I'm afraid. This is a special candle. Now you should be able to see it. I can pour this beaker full of water without putting out that second candle. At least it appears that way, doesn't it? That's a very simple optical illusion, and I don't have a very good setup here for it. But this is the kind of thing they use in a lot of movies where you see something and you know it isn't there. Usually you trust your intuition on that. I can make them both disappear. Keep that one.
Oh, that's a
See
good
that?
one. I've done that one,
That's
yeah.
why I didn't want her
Yeah, that
candle.
was good. Okay.
This one's made out of apple. It tastes kind of good.
You know what I do? I make it out of potato when I make mine.
Potato does the same thing. Doesn't taste quite as good as apple.
Yes, you're right. Get your recipe.
Who wants to guess what the wick was made of? The apple stem. Sometimes just for fun, I put a wad of string in my mouth and I pull the wick out afterwards. But that, you would have known right away, as intelligent as you are, that wasn't real. Well, you knew right away this wasn't real, because I told you I was going to show you an illusion. No, all it takes to burn like that, this was a little bit dried out, because I had them for over a year. And I didn't get fresh ones. That was just a simple almond stick, splintered almond, that you can buy in a grocery store. And that's kind of fun to do sometime if you want to fool somebody. I just took an apple and made the candle out of by pushing this little tubing through the apple and then taking it out of the tube again. But I hope you could see that what doesn't seem like a possibility of a candle burning on the top can very often be shown and fool a lot of people by a simple optical illusion. And it's not difficult to do with special equipment. That was why I wanted that extra book, so that I could set this up so that it would hold that piece of glass. But this is just a simple piece of window glass that today I cut the corner off of. What are some of the other things that you think of that everybody knew was an impossibility until it was done? So you can turn those lights on again if you'd like. This is what splintered almonds look like. They're just a simple almonds cut into strips. And I got a whole bunch of them here. They're the smallest package I could buy a year ago or something. I got them. To cut up into cakes or ice cream or something. Okay, just missed that. When you think of the history and science you study, what are some of the impossible things that you're aware of, the possibilities? One of them I remember so clearly was shortly after I finished college. I think it was in my first or second year of teaching, where I went to a symposium put on by AT&T. And one of the young engineers there said that some of us, maybe, would live long enough to see the time. This was at a time when we still had crank telephones. And I had strung telephone wires to different places to put a telephone there. But this guy was so ignorant of reality that he said that we would probably, some of us, live long enough to see the time when if we knew somebody else's phone number, we could take a telephone out of our shirt pocket, we can dial their number and talk to them no matter where in the world they were. To me, that was an absolute impossibility. I knew more than that. And how long we've been doing that? 10 years now?
Yeah.
Yeah. And it's so simple now. You can buy one of those. In fact, if you want to sign a contract for a year, they'll give you one of those guys. Impossibilities that became reality in a relatively short time, during a time in history that things were changing rather slowly in terms of what they'll change in your lifetime. And that was why I mentioned driving your car on a spoon full of gas. I started college in 1949. None of you remember that. That was the year that the Indianapolis 500 outlawed gasoline for a fuel. Since that time, they will not allow cars to run in their race on any petroleum fuel. They've used alcohol ever since then. Why? Because it's safer. Nobody will ever burn to death with alcohol. Should have asked Ms. Duyan for a sample of methane or methanol.
Would you like some?
Yeah, I would. I'd show them one more thing.
Okay.
The reason they use alcohol is that it doesn't leave any residue on the bricks. That's a brick track. And the exhaust of the car burning half a gallon of gas on every mile like they were doing, and to get the kind of power they get off those big Offenhausers and other race cars, made that track so slippery that there were a lot more accidents than there ought to be. They'd have to scrub that down with alcohol or water or something with soap in it to get the grease off the bricks before they could run another race. And so they just said, no more gasoline. That was a long time ago. Most people's terms. It doesn't seem very long ago to me, not anymore. But we're back to 59 and 99, that's 40 years. But they've used only alcohol on that track. And yet when people started to want to burn alcohol and mix it with their gasoline, the car companies and petroleum companies said, no, that's impossible. It won't work. Those engines won't run on it. Our car companies have been making engines for over 15 years for the company of Brazil. Anybody here from Brazil? How long has it been since they allowed cars to run on gasoline?
I was just cooking.
Okay, it's been about 12 or 15 years. can only burn alcohol in the same engines that Ford and General Motors and all the others make and ship to Brazil. You got some there? Yes. Oh, good. I'll need some help with this one.
How much did you want?
Oh. Give me half an inch. You want a light for me? I'll ask
I
this.
used to have one of those, you know, one of those, things they use when they, do,
Methane evaporates very quickly. If you put it on your finger, your finger's dry again in just instants. And you know that the heat usually evaporates things fast. If I get a little bit of this methanol on my finger and then ask this to be on to light it, you'll see that. Won't get my finger hot, but it'll burn the alcohol out.
Ready?
Yeah, I'm ready. Pretty well soaked up. Didn't burn it.
You can light it.
This is methanol solution. You get a percentage of alcohol.
Oh, you're right, I did, I guess I don't.
Okay, I thought that doesn't burn like alcohol. That should be lit right up.
You were right, Dr. Rome. I'm glad we saw that, I didn't know.
Thanks, Miss.
Well, I didn't see it before I noticed it wasn't alcohol. What time does this last?
55. So you have about a half hour.
I didn't know if I had time. Now, this is methanol?
Do we have English on this?
Yeah, this is the way
Just to
methanol,
read,
I
I
can
think,
feel
and
that
give you
difference. See
vocabulary.
it burn? I always shake it off before it gets hot on my fingers. Could you see that? Would you turn the light off
Do it
one more
again.
time?
Can you do it again?
No, I couldn't. A little bit too light here. Alcohol burns almost as colorless as hydrogen does. Ready? Okay, go ahead.
Close up with that finger here.
There you see it.
Oh, my God.
Yes.
Doesn't make my finger hot.
Miss Duyan, you do it now, Miss Duyan.
Sometimes I let it burn so long it singed the hair a little bit, but it doesn't get hot. As soon as it gets hot, I shake it off. Because that alcohol burns without getting it hot. That's why you don't hear of people burning to death anymore in the big races. The whole car can burn up. Alcohol burns and evaporates and cools as fast as it burns. So as long as you're not above the fire, don't ever do that with your hand this way, because it'll be on your next finger. It gives off a lot of heat. That heat goes up and cools underneath it. And that's why they don't allow any fuels except alcohol in many of the big races now. But it started with the Indianapolis Speedway. I was going to show you that hydrogen is much the same. Did everybody get a chance to read those facts in there? They're kind of unbelievable, aren't they? We can turn the light on again now. Well, maybe leave it off until I show you some hydrogen burning. I want to be sure that I've got pure hydrogen gas here. I could put it in a test tube to test it, but I didn't want to take that much extra time. So I'm going to try it, just like I can usually tell by watching it burn, whether it's pure hydrogen. I had quite a bit of air in this line. That should clear up as it replaces the air in that line. That's burning a little more colorful than you usually have with pure hydrogen. But other than that, it burns.
And it's
Right.
supposed to be,
Pardon?
it should be pure hydrogen.
Yeah, it should be. That's what the can says.
Yeah.
I might
Before
have
I've
had
got
some-
it, I double checked the can.
Yeah, I might have had some impurities in this too. I'm going to let it burn a little bit because I want to have as pure hydrogen as I can. What happens to hydrogen when it oxidizes? Pardon? It's water, yeah. Pure water. If you get 2 parts of hydrogen gas and 1 part of oxygen, you have water. In the gaseous form, it takes up a lot of space. When it combines, it forms water vapor, which also takes up a lot of space compared to the water that's in it. Yeah, we're getting a better color here now. What I want to do now is put this light out, and then I'm going to fill this Pringles can with hydrogen gas and ignite that. How does the weight of hydrogen compare to the air? Anybody know? Heavier or lighter than air?
Later.
Lighter, yeah, much lighter. It's only about 1/4 as heavy as helium, which many people think of as the lightest gas, but that is an atomic mass of 4, where hydrogen has an atomic mass of 1. So if I fill this with hydrogen, then it'll escape out the top here. And as it does that, air will come into this bottom hole where I put the gas in. And gradually, as the hydrogen leaves, air will come in here, which is what % oxygen?
Think of air, what's the percentage of oxygen in air?
About 1/5, isn't it? 20 to 27%?
Roughly
That's the numbers that come to
21%.
my mind.
It's 21%, 78% is nitrogen, 21% is oxygen.
So by the time, to get an inch of oxygen in here, I'd have to have 5 inches of air. So as that hydrogen gas burns out and air replaces it, it'll reach a point where it's H2O, where there's 2 atoms of hydrogen for each atom of oxygen that's in the can. Then we'll have a sudden implosion. It sounds kind of like an explosion, but this is something you've seen, all of you, in nature regularly. When the wind blows through the atmosphere and causes friction, that is enough electricity to separate the water in the air, the moisture in the air, from water to hydrogen and oxygen. And when they reach the right proportions, that friction will cause enough of a spark to ignite it. That's what we call lightning. And what you hear if you're close to a bolt of lightning is thunder. That's the kind of an implosion that you'll hear today when I do this. Now, I'm doing it with a very small amount, so you'll have to be listening carefully probably to hear it. But that's what I like to show, and it surprises some people when they see that actually happen. What I'm going to do now is turn this on.
Do you want me to turn the light on?
Yeah, might as well, because they'll see. Although they might see the lightning if we don't.
Okay, well, we can maybe do it this way.
Can you see everything here? Is this light enough to show up on the film? Let's just leave it off.
Okay.
Well, I can hear them blowing air in there. I want to get that clear full. Then I'm going to ask somebody close here to come up and light it for me. But I want to keep my hand on there. Would you do that? Yeah.
What do you want me to
I
do?
want you to just take the command so that I can hold both hands here. When I take my finger off, I want you to just light that right under my finger.
Right under that?
Right? Because the hydrogens being very light will start to come out of there. And I don't want to let air out, so it takes both my hands here. I keep this bottom hole plugged until we get it burned. Are you ready? Okay. There you see that hydrogen burn. That's why I wasn't especially careful to have the lights turned out. As that burns, you can sit down. It'll reach a point where what's left in that can is 2 parts hydrogen for each part of oxygen. This is just a paper box, a regular Pringles box, so I've done it many times, and so you know it isn't going to blow in your face. That's thunder.
I'm not gonna run out there.
Pass it around.
That was good too.
You guys recall when we did the zinc, hydrogen chloride, and we did put zinc in it? Remember
did
you
that
had to
wooden
put a
spoon in
burnt
there.
wooden splint? Right,
Now, that amount of hydrogen and oxygen
that's a
would have
big.
formed only a very small amount of water, less than a drop.
This whole world was never getting ready to take off.
Now, that's not an explosion. If that had been an explosion, some of you probably had the experience of putting a firecracker in a tin can.
Oh, yeah.
Oh, that's a small amount of power compared to this, but it'll blow a tin can all to pieces because it's an explosion. This is an implosion. If you figure it out with the chemistry knowledge you have or will have, you'll find out that what was about 400 parts in volume went to about 1. About 1 in 400. The water that was formed occupies about 1/400th the space that the hydrogen and oxygen gases occupy. So if you can come up with a carburetor and a generator that will take common water and turn it in to hydrogen and oxygen, which we do with electricity all the time. That's how a lot of the industrial oxygen is made, is with electrolysis of water. You get twice as much hydrogen as you do oxygen. And we use the oxygen in all kinds of industries and hospitals and homes where people need a supply of pure oxygen. And we hardly use any of the hydrogen. So hydrogen gas right now is the least expensive gas in the United States. And about the only use that's made of it is in spaceflight. The space shuttle that's up there now, that's coming back about, what is it, 6 days earlier because they had a problem with the generator on it, was sent up there with liquid oxygen and liquid hydrogen with 3 engines like the ones described on this piece of paper I gave you. Do not do any polluting. Incidentally, we didn't pollute the air in here because all we did was form pure water. If we'd had that kind of an explosion with gasoline, we'd have had a problem, including pollutants in the air. You will see the time, I'm pretty sure, when we use a teaspoonful of water to power a car much further than a tank full of gas will right now. But it's going to take somebody who doesn't know it's impossible to develop a generator and a carburetor that will burn water. Yes, question?
So they haven't developed anything that we can use water to generate energy yet?
Not that's controllable at the level of that. We do it in industry all the time. They use water, separate it into hydrogen and oxygen with electrolysis.
Why don't they do that now?
Yeah, they do that now. You can go anywhere almost and buy oxygen gas. It's hard to buy hydrogen gas because there's no demand for it enough for them to commercially operate it.
But the two combined together are explosive.
Yes.
And then also, don't they have concerns about hydrogen with air?
Well, see, that we did here. We burned it with air, with the
Right,
oxygen.
we didn't have a lot of it though, but if they had massive amounts, because aren't you talking about massive amounts?
Yeah. Well, you know, a gallon of water will make a tremendous amount of hydrogen gas. If we could put that into our car some way and carburate it into the engine like we do gasoline, controlled way so that we can increase and decrease the amount of power that we get out of that hydrogen gas. We'll not only drive cars with it, we'll fly airplanes, and which we're already doing. Incidentally, right now, and this has never been made public yet, but it's been true for about 3 years, the United States has an airplane, flies on pure hydrogen gas and liquid oxygen. It'll take our president or anybody else that has to go somewhere in a hurry, any place on earth in less than an hour. We already send satellites all the way around the earth, a couple hundred miles out in an hour. This is an airplane that could take off in Rochester and land in Bangkok or anywhere else we wanted to within 1 hour of the time of takeoff.
Isn't that the Concorde?
No, the Concorde goes about a third that fast.
Right.
The Concorde goes up to 3 Machs, or 3 times the speed of sound, which when I was your age, was just unthinkable. We couldn't even break the sound barrier. And now we do it all the
Who broke the sound barrier, you guys? Chuck Yeager, good.
time. Right.
Do they use that plane?
Pardon?
Do they use that plane?
The Concorde?
No, the one that
Oh,
goes
no,
in and out.
not publicly. No. There are a lot of things we do that aren't public. The Blackbird that some of you have probably read about, which was one of our spy planes, flew for 30 years and they discontinued it because they had a better one before they ever made public that we owned it. Any other time it was seen, it was called an unidentified flying object. I was in the service in 1953. just before we launched the first atomic submarine. And one of the things I will never forget was one night that I was on guard duty because some VIPs had flown. I was stationed in Georgia, Camp Stewart, now called Fort Stewart, where they had a pretty big airstrip because in World War II it was used as an air base. We had to guard this one area because the VIPs were there at a meeting, and I was at the door of one of the buildings where they met and didn't know anybody that came in and out at the time. I got to know who they were later. They included President Eisenhower, who was the person who first said when he was put in charge of the troops in the European invasion in World War II, and he saw the impossibilities of that project. He said, well, the difficult things we'll do immediately, the impossible things will take a little longer. He was president at the time I was in there in service, and he met in Camp Stewart with some of the higher-ups in Macon, Georgia, that's where they developed the first atomic submarine. But included in that meeting was then Senator John F. Kennedy, who was head of the Armed Services Committee, and a man named Albert Einstein, who was in charge of the research at Macon. I wouldn't have recognized them if they'd walked right in front of me, but I learned afterwards they were some of the people there at that meeting. People almost my own age. If you don't come up with some of the things that are possible that we think are impossible, I'm pretty sure somebody about your age will. There'll have to be somebody who doesn't stop thinking just because somebody's told them it can't be done. If they fail, they'll recognize that it's really not a failure, it's a success in finding something that doesn't work. I hope that makes sense to you, and I hope it spurs some of your thinking, to not let somebody tell you you're stupid. That can never happen. Because you're probably only 1 or 2 generations ahead of their thinking. Now, I'd like to have you, if you haven't already digested those figures on that engine, keep those and compare them sometime. You'll see things change in the next 5 to 10 years where these things will be commonplace. And not only will we be flying out to space centers orbiting the Earth, we'll be flying to Mars, Jupiter, Pluto. I hope wouldn't be shocked if you or some of your children or grandchildren got there. For people who haven't thought ahead, I'd like to tell students to be sure you're aware that if your parents had any children, you probably can too. Because it's not an impossibility. We recognize that as a possibility pretty easily. But there are things that your parents and others in your generation never dreamed of that you'll see come to pass, because I'm sure of that. Because already there are a multitude of things that I knew were impossible that are now just as commonplace as picking up a telephone and dialing one of your friends wherever they are. Even if they're on the job, their phone will buzz and they'll stop what they're doing and talk to you. Unless they've got a caller thing and says, no, I don't want to talk to her, or I don't want to talk to him today.
They had a special, they have a station here called TLC on Channel 16. The other day, it was sort of frightening when you saw some of the things they have planned. They have, the amniotic fluid. They're trying to make an artificial uterus so that for women who can't carry, that they will put the embryo in the, I was stunned. And also they're talking about putting the uterus in a man, putting the uterus in a man. I mean, these are all things that are, and then they have another guy who was transplanting brains, animals to humans. It was, I'm going to tape it and bring it to class so they could see, because it was sort of scary. They were saying that this man, because this came about with the sheep, when they cloned the sheep. It's been going on for, all this stuff is coming out. They've been cloning all these different things now, and it was just like really sort of.
There have been a lot of things like that, not exactly like that, but close to that. One of the fun things I did in biology lab in college, we worked a lot with fruit flies because you can multiply them by the thousands. And we found out what the imaginal buds were. The buds like to produce a leg or an antenna, and just for fun, in the very early embryonic stages of some of those fruit flies, we took the leg buds and put them where the antenna were, and the antenna where the legs were, and when those eggs hatched, those fruit flies had legs on their head and antennas on their tail. Their feet should be kind of cool maybe in a way, but we didn't think of it that way because you just make thousands of them in a day. I have always said, how many of you know what cattle are like? But maybe even raised some or seen some, most of you probably have. They're one of the creator's mistakes, I think, to put a tail on them in the rear and horns in front, when really they need their tail on top of their head so they keep the flies out of their face. And I've often thought it'd be fun to do that with an embryo and put their horns in the rear so they can protect themselves from the rear and put their tail on their head so they keep the flies out of their face. Wouldn't that be an improvement? Everybody says it's impossible. Yeah. Does that raise any other questions in your mind? I hope you don't ever stop thinking of crazy things, because they're not as crazy as they seem. And the more you think about them, the more real they become. I'm sure that the Wright brothers were among those people who for 100 years or more, they had proven over and over that man would never fly. How would we feel now if they hadn't kept going? We came out here from South Dakota, and we left at 5:45 in the morning. We were supposed to be here at 1 o'clock in the afternoon. We had about a 7-hour layover in Detroit because somebody goofed on one of the airplanes. They had to cancel the flight. And we had it took a while to make other connections. But we expect to fly back. But right now, you could leave here and say you had 7 o'clock breakfast here, you could fly to San Francisco and eat breakfast at 7 again, then you could fly to Tokyo and eat breakfast at 7 and go to Moscow and eat breakfast at 7 and Berlin and eat breakfast at 7 and you'd be back here by 7 o'clock the next morning and you wouldn't even know it was another day. I think that's what Eisenhower was talking about when he said, if you ever approach the speed of light, time will stand still. Can you imagine how far you'd go in a day if you went the speed of light? You'd go from here to Mars and back several times. And your best buddy probably wouldn't have shaved since you left, and your girlfriend still have the same hairdo. And you've gone further than you ever could imagine in a lifetime, but you do it in a day. I think you'll see that. Well, if you don't see that happen, I think your grandchildren will. Because Eisenhower and Albert Einstein were my generation. Kennedy and the greats of his time were in our children's generation. And we don't really even know yet who are in the generation of our grandchildren, except that it could very well be any one of you, or any one of them. I think Leah can do millions of things I would never imagine I could. I'm still computer illiterate. If I have trouble with a computer, I ask one of our grandchildren. Because they know it so much better than I do. I have fun doing things that were impossible when I was a child that are possible now. I hope you will have the same kind of fun in life. I hope you'll help others think freely and not help them slam on the brakes just because you think something's impossible.
What discovery or what invention do you think is the most important that you've seen from being a child to an adult now? What would be the most fascinating or important that you can relate to?
Oh, I guess 20 years ago I'd have said television set, because I never imagined we could ever see what we were hearing on the radio. When I was in high school, we didn't even have electricity or running water in our home. So they were great advancements in their time. Now they're so old hat that most of you can't even imagine living without at least 2 bathrooms in a home. Our bathroom is 50 feet from the house. I used to tell a story about the first time we put carpet in the bathroom. Felt so good we went back to town and got enough to go clear to the house. That wasn't true, but it sounded. I guess right now, I think the greatest accomplishment is the hydrogen engine. Because when you take the constituents that are in water, which is all over the earth, unused, most people think invaluable except for eating and growing plants and stuff, and power space flights with it, that just blows my mind. But we do it every day now. And we don't think anything of it. Liquid hydrogen and liquid oxygen are what they use. They liquefy them simply because they need to contain them in a small area. When you start using them in your car, you may not be that close. You saw the power that we got here out of about 1.5 inches of hydrogen in that Pringles can. If you had a tank full that you could put in the back of your pickup, even in a gaseous form, you could drive that car a long ways because you could use the oxygen that's in the air, and all your exhaust would be is water. You'd have a little bit of heat to dissipate, but not very much. Because when that water, which is what is a gas when it forms, when that condenses and becomes water, it soaks up a lot of heat.
It'll be pure, right?
Pure, yeah. No impurities unless you put them in the tank. Because hydrogen and oxygen does not pollute. That's the same kind of water we use all the time. We got too much of it right now in South Dakota. Too thick. We've been having a blizzard out there for 3 days. I'm glad I'm in New York.
Yeah, that's not gonna affect your travel plans at all?
I hope not. I just called the neighbors that are taking care of our livestock. And we've got little lambs, with 11 of them on the bottle. The cow's about ready to calf. So we thought this was a good time to come and see a couple of our grandchildren, and our son, of course. And they said they've been able to drive with their four-wheel drive from their place to mine, which is about a half mile. But they had to walk from the house to the barn. They can't get through there. There's too much water and too much snow. They've had a blinding blizzard for the last 2 days. They couldn't see their mailbox, which is less than 100 feet from their house most of the time. Well, I guess one of the other things I'm so glad for is transportation like this. I'm sure that my grandfather never got more than 200 miles from home. And if he went 200 miles from home, that took him several days to get there. I'm sure that I shouldn't say that, but I'm sure, because this might be my last day on it. None of us ever know that till the time comes. But pretty good chance that I'll fly to Europe this summer. I hope to. Our daughter works over there about 1 day out of the month. And my wife and I can get the time. We're going to fly with her next time she goes to Paris, I think, and do some sightseeing and take care of her little kids while she works. To my parents or my grandparents, that would have been so unbelievable that they would have laughed at the idea. Wouldn't seem unreal to any of you, but pretty good chance you will travel more than I have ever traveled. Even if you don't get to another planet or another solar system. By the time you're my age, and I hope that happens, at least you'll be able to see in the foreseeable future when we'll be traveling through space that easy. Right now, there's on the runway the follower of the present space shuttle that can take off on an airstrip like you have right here in Rochester and go right into orbit. Powered with hydrogen and oxygen. Powered with water. It's much simpler to separate water into hydrogen and oxygen than it is to separate crude petroleum into lubricating oils and gasoline and diesel fuel. That's a complicated process compared to separating water into hydrogen and oxygen. Maybe sometime we'll even be able to use more atomic energy than we have. Most of you know that the atomic submarine, which has now been a reality for 40 years, and was always impossible up until that time, doesn't have to resurface for fuel. Submarines before that had to resurface about every hour and a half to refuel their diesel tanks. Now the only reason an atomic submarine has to go into port and surface is to change crews. They can go for 2 years without refueling, but people can only stand being confined that much for about 6 months. So they find they have to change crews about every 6 months. They can go under the ice cap around North America, which I never thought would ever be possible. And they do it so routinely that they don't think twice about it. They go all over the world. And and they surfaced to change crews. That's what those guys were deciding when I was in Georgia. As a guard watching the door, and nobody got in who wasn't supposed to get in. And they were deciding when to launch that first submarine. If you could have read the newspapers, and I wish I'd have kept some of them, because the press was always criticizing President Eisenhower. He was going to Macon and wasting his time golfing. Because that's what he was supposed to, I mean, that's what he supposedly was doing. And I've seen that with every president since then. Kennedy had his yacht. People in that kind of a responsibility have to have a place where they can get away from the public, because they're doing things that should not be public. But when you read rotten things about public figures, recognize the fact that they may be doing something so important that they don't dare let us know about it, because if they let us know about it, everybody in the world will know about it. Does that make sense to you? I hope I've encouraged you to do some thinking today. We've got time to make a little more water. Would you like to see one more? Now you know what to expect. Is it worth it?
Yeah.
I think we got enough hydrogen in the can. We'll do it once more. I don't know how it. I just turned this on until I think I've got the can full of hydrogen.
She only plugged the top one.
I'm not getting any for some reason. Maybe I need to all. I must not shut that valve off tight enough. I don't have all that. Sorry about that.
Oh, that's okay.
At least you got to see it. How many were surprised by it? I'm always surprised
I
by
think
it.
they will, everyone was surprised.
I think that's the same Pringles can more than 20 times. It still looks like meat. So you know it's not it's about olive oil pressure.
She just fill it up with gas and then lights the top part.
Yeah.
And it makes a flame out the top, and when the flame goes down, it concentrates.
Yeah. When the flame gets so low.
Did you hold the bottle when it exploded like
Yeah, I keep a hold of it because otherwise, once you hear it, the air rushing back in to fill our vacuum.
Don't pay the price.
It'll push that can up
Did
the
you
ceiling
still plug
sometimes.
it inside wall?
Would it go?
No, I let the side hole open so air can get in.
Oh, so it would jump up in the air if you didn't hold it
Yeah,
down?
if I hadn't been holding it, a couple times it slipped out of my hand and it hit the ceiling, leaving little marks sometimes, but no damage.
It's a Pringles can.
I always-
It's a Pringles can.
Like I told Ms. Duyan, I usually try to let the teachers around the classroom know, so that when they hear this explosion, they don't call the police and 911.
But you know what? The reason why they said that, I don't think usually we're the only ones on this hall.
Yeah. No,
That's
Miss
why-
Harris.
Well, she's way down there, she wouldn't hear you.
Yeah.
That's why they bothered to say anything.
Well, see, I noticed that, Ms. Duyan, when I was here, that, you're really isolated, and that's good for
We
them.
are pretty isolated.
She got 140.
Well, thank you for your attention. I was going to put down a few things. Thank you, I appreciate it.